Hello dear students. So in the last session we have discussed about the aldol condensation, and today in this video I'm going to show you how this crossed aldol condensation can be learned very easily. So the first thing that you have to note it down is, in the case of this crossed aldol condensation, we are carrying out this reaction with the help of two aldehydes or two ketones which is having alpha hydrogen atom. So the one thing that you have to note it down is, if both of them contains alpha hydrogen atoms, it gives obviously a mixture of four products. So this point is very important that you can note it down. So obviously you can write the first point, so that tells what is crossed aldol condensation is. So apart from that, the very important point that you have to note it down is, note if both of them contain alpha hydrogen atoms, then it gives a mixture of four products. So that is very important thing. So when you take two aldehydes and it contains two alpha hydrogen atoms, then you can expect four different products. So that is what we are going to see in today's class. So let's take one example. Okay, so let's take an example of acetaldehyde, and one is an aldehyde which is having 3 carbon atoms. So I will be taking acetaldehyde, that means ethanol and propanol. So take the example CH3CHO. So this is what we are calling as our ethanol, or we call it as acetaldehyde. And when this ethanol is treated with propanol, so that is CH3 CH2 CHO, in the presence of some dilute base, so you can add it as NaOH, dilute NaOH, and when you heat it, so the second step is heating. So what happens when these two reactants react together? So in the last case of aldol condensation, we have already learned how this reaction is occurring, how the bond is actually forming. So it involves the bond formation between the carbonyl carbon and alpha carbon atom. So this is the same trend is also following in the case of crossed aldol condensation. So you can expect here also a bond formation between alpha carbon atom of one aldehyde and also the carbonyl carbon of another aldehyde. So since here we are taking two different aldehydes, you can expect, and both of these aldehyde carries alpha carbon atom. That means, so this is the alpha carbon atom here, and this is also the alpha carbon atom here. So in both of the cases you can see the alpha carbon atom and the alpha hydrogen atom which is associated to that, so that you can expect four different products. So let's see how this reaction is going on. So first of all, we have to analyze what and all possibilities are actually present over here. So the first possibility is this acetaldehyde can react with another molecule of acetaldehyde. That means the condensation can occur between these two acetaldehyde, or else you can say that this propanol can react with another molecule of propanol, and again a bond formation between this alpha carbon atom and the carbonyl carbon atom will take place. And the third possibility, you can say that the alpha carbon atom of propanol and carbonyl carbon of acetaldehyde reacts to give a product, and the reverse can also occur. That means alpha carbon atom of acetaldehyde and carbonyl carbon atom of propanol can also take place. So I will show you, I will illustrate you, and so that you can easily understand how this reaction is actually going on. So let's see how this reaction is taking place. So for that I'm taking a new page. Okay, so here the first combination that I would like to show is our previous aldol condensation. That means here acetaldehyde is reacting with another molecule of acetaldehyde. So let's see like this. So CH3 CHO. That means this is C double bond O, and this is our H. Okay, CH3CHO. And I will show you the another molecule of acetaldehyde in different colors so that you can easily understand that. So this is H, and this is CH2, and this is our CHO. So hope you remember this reaction in our last uploaded video of Aldol condensation. So what happens here? So since this oxygen is more electronegative, the bond will be shifted towards oxygen, and this carbon becomes positively charged. And what happens here? See this bond, this negatively charged oxygen will abstract a proton from the nearby aldehyde. That means that will abstract the alpha hydrogen atom like this. So this bond will be shifted to this particular carbon, creating a negative charge over here. So what happens here? This negative charged oxygen atom will take or abstract this particular proton, and the negatively charged this carbon will attack this particular carbonyl carbon of this aldehyde. So this reaction will take place only in the presence of dilute alkali. So the expected product will be, I can show like this. So this part will be CH3, and this is our CH, and here will be OH, and here it will be CH, and here also H, and here we are having CHO. So we understand that how the product is formed. So or else I can show in a different color so that you can, or there is no need of showing in different color. This is fine, I guess. Okay, so what happens here now? See, listen. So when you heat it further, what happens here? Elimination of molecule of water will take place. Elimination of one molecule of water. That means minus H2O will be eliminated from here. So that creates the final product, that is CH3 CH double bond CH CHO. So this is the first possibility, or this is the first product formed in this crossed Aldol condensation. So that means here the bond self condensation of acetaldehyde is taking place. Okay, so what is the next product that you can expect from here? So in the next case, you can say that this propanol can react with another molecule of propanol. That means this is our propanol. This propanol can react with another molecule of propanol. So I will show over here. So this is our CH3 C double bond, CH3 CH2. Yes, CH3 CH2. Wait. Okay. CH3 CH2 C double bond O H. So this will condense with another molecule of propanol. So I will show over here as I shown in the previous case. So here this carbonyl carbon will make a bond with alpha carbon atom of another propanol. So the alpha carbon atom is this one. So here you can say that H will be here, CH will be here. So this is our CH3, and here it will be our CHO is there. Okay, so if you understand that, so if you are able to understand what is happening over here, or for easiness I can show this CH3 below of it, so that it is easy to eliminate one molecule of water. Okay, see here. So what happens here? So as usual you can say that this bond is shifted over to more negative oxygen atom, creating negative charge over the oxygen. And what happens here? This carbon will have a positive charge because this carbon becomes electron deficient, and this minus oxygen will abstract a proton from the nearby aldehyde, that is this hydrogen is alpha hydrogen atom, so that this bond will be shifted over here, creating a negative charge on this particular carbon. So what happens here? This negatively charged carbon will attack electron deficient carbon of the nearby aldehyde, and that creates the product as CH3 CH2. Okay, so COH. Okay, here one hydrogen is there. Now I will show in a different color. So in the previous example I forgot to show this in a different color, so no problem, here I can show that. So here comes the another molecule of the propanol. That means the alpha, here you can see how this alpha carbon atom is successively forming a bond to the carbonyl carbon. So it involves a bond like this. So here it comes CH. Okay, so actually the H, this H is actually, I have to show in white color because this proton is abstracted from the nearby aldehyde. That means this hydrogen is actually the hydrogen, that means alpha hydrogen from the nearby propanol. Okay, so here comes the CH3 part, and here we are having our CHO. So we understand that. So what is the next step? What is the next step? So next step is just heating, and you can say that elimination of water molecule is taking place from here, so that this OH and this H will be eliminated from here. So that forms the product CH3, CH2, CH, double bond C, and CH3 here, and here CHO is there. Okay, so we understand how this product is formed. So till now we have written two products, and these two products are resulted by the condensation of the same type of aldehyde. And now we are going to see how the condensation of two different aldehyde is actually going on. Okay, so for that you can see over here, so I'll be taking one molecule of our acetaldehyde and one molecule of our propanol, so that you can understand it, how this reaction is actually going on here. So so this is the acetaldehyde. So here I will show the bond formation of carbonyl carbon of our ethanol, that means our acetaldehyde. So here comes CH3C double bond over here, one H over here. Okay, so the other molecule is our propanol. So it comes over here, the alpha hydrogen atom over here. Okay, CH3 will be here, here it is CH, and here it is CHO. Okay, so don't forget to write dilute and NaOH over here, because these reactions will take place only in the presence of dilute alkali. Okay, so what happens here, as usual, this bond will be shifting over here. So here comes the minus charge, and this carbon becomes positively charged, and this minus oxygen will abstract proton from, that means abstract alpha hydrogen atom from the nearby aldehyde, so that this bond will be shifted over here, creating negative charge on this particular carbon, and this negatively charged carbon will attack over this electron deficient carbon. So here comes the product. So you can write like this. So it forms CH3, and here comes COH over here. Okay, no problem with that. Here it is H, and again I am forgetting to show this hydrogen in the white color. Okay, so this is that hydrogen that is abstracted from the nearby alpha carbon atom. Okay, so you can see here, this is our CH. Okay, this is our CH, and here we are having CH3. So better you have to show this hydrogen on the carbon atom, so that you can easily eliminate the water molecule. You can easily learn or you can easily understand how this water molecule is eliminated. Okay, CH3 over here, and here we are having the CHO. So we understand that. So what is the next step? So what is the next step? Next step is just heating, and that eliminates one molecule of water. So you can see over here this OH and this H. So always remember, in the last session of our Aldol condensation, that means the last uploaded video, if you haven't watched that video, please kindly watch that video and kindly listen this class after watching that video. So hope you remember that. Here when the water is eliminated, an double bond is coming on the alpha beta position. So when the water molecule is eliminated, you can see that a double bond is coming on the alpha beta position. So this is the alpha carbon atom. That means the carbon which is nearer to this functional group is alpha carbon atom, and this is our beta carbon. So if the double bond is coming on the alpha beta carbon atom, no problem, you can say that the product is 100% correct. So here also water elimination is taking from the alpha hydrogen from on the alpha carbon atom and OH on the beta carbon atom. So that results the formation of double bond on the alpha beta carbon atom. So that is the important tip to learn this aldol and crossed aldol condensation, so that you can cross check by yourself. So it forms the product. I will show in a blue color. So it will be CH3, and this will be CH, and this will be our double bond over here. This is C, this is CH3 over here, and this is our CHO. So finally we arrive to the final product. So CH3CH double bond C, CH3CHO. So here you can see that the bond is forming between carbonyl carbon of ethanol and alpha carbon of propanol. Okay, so this could be there is one more possibility. That means the bond can also be formed between carbonyl carbon of propanol and alpha carbon of ethanol. So that is the final possibility. That means the fourth possibility. So let's see how that reaction is actually going on. So I'm directly writing that reaction. So first you have to show the propanol. So propanol is CH3, CH2, CHO. So this is our propanol. Okay. So you have to show the alpha hydrogen atom of ethanol. So that I will be showing in a different color. Okay. So H, CH2, CHO. So here also you can easily write the reaction. So if you're writing along with me, I think there will be no any room for any doubt. Okay. So what happens here? Here also the same process, same reaction. This double bond is shifted over to this particular oxygen that comes with a negative charge on this oxygen. And what happens here? This negatively charged oxygen will abstract this particular hydrogen atom. Here one positive charge will be coming on this particular carbon because the double bond is shifted to this oxygen. And this bond is completely shifted to this particular carbon, creating a negative charge on this particular carbon. And the bond is formed between like this. That means the negatively charged carbon will attack the electron deficient carbon of the nearby propanol. So you can write the product without any doubt. So that is CH3, CH2, and here it comes C, OH, and here H is there. And now so again I'm forgetting to show this H in white color so that you can understand this hydrogen is coming from this particular ethanol. Okay, now you can show the product. So here it will be our CH2, and here it is having our CHO. Okay, so what happens when you heat it? So here you can show this hydrogen to show the elimination of water, so that you can show like this. Okay, see what happens when you heat it. One molecule of H2O will be eliminated. So what? Nothing. This OH, that means hydrogen on the alpha carbon and OH on the beta carbon, will be eliminating one molecule of water. So that forms a double bond on alpha beta position. Okay, so it forms CH3, CH2, and here it comes CH double bond CH, CHO. So this will be the final product. So hope you understand the crossed Aldol condensation. This is a very easy reaction. So let's see the steps that involved. So here you can see that I haven't written the 4 products over here. Instead I have shown the 4 different possibilities of forming 4 different products. So let's see, let's name these compounds based upon the IUPAC rules. So what is this compound actually? So this is 1, 2, 3, 4 carbons are there. So the parent will be bute. So you can say that you can give the name as bute 1, 2. On the second carbon there is a double bond, so bute 2 enol, bute 2 enol. And what about this particular carbon, this particular product? So this will be our you can number it 1 2 3 4 5 pend. So that is, you can see one branching over here. So this is 2-methyl 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 1 2 3 4 5 pend. On the second carbon there is a double bond, so pend 2 enol, pend 2 enol. So that is the second product. And what about this product, the third one? So you can name it 2-methyl 1 2 3 4 carbons are there. So 2-methyl but 2 enol. Okay, so 2-methyl but 2 enol. And the last product, that means our fourth product, you can name it 1 2 3 4 5 carbons are there. So you can name it as pend 2 enol. So this is our aldehyde. So pend 2 enol 1 2, second carbon, this is double bond. So hope you understand the products formed in the crossed Aldol condensation. So kindly practice it. Hope you understand the reaction mechanisms involved. So there is nothing to worry about the crossed Aldol condensation. You can do as like our same Aldol condensation. If you understand the reactions in the Aldol condensation, then you can easily understand the crossed Aldol condensation also. So thank you all. We will discuss one more example in the next video session. Until then, take care. Bye bye.